Hi Bobcats! In this video we're going to take a look at something called Avogadro's law, which talks about the relationship between the amount of gas or the number of moles of a gas and its volume. One of the things you can think about to illustrate this is blowing up a balloon. Let's say you take a balloon and you puff into that balloon one time. And you get a certain volume, and then let's say you breathe into the balloon again and its volume gets bigger. That's all Avogadro's law is saying. As you put more gas into a sample, its volume is going to get bigger, assuming that you're holding pressure and temperature constant. In this slide, I'd like to illustrate Avogadro's law visually, and the image over here on the left-hand side just shows the gas container, and I set some settings over here. I asked it to hold the pressure constant. I could only have it hold one thing constant at a time, and I'm not doing anything that's going to affect the temperature, so I just figured, yeah, let's let the pressure be held constant. In this image over on the left, I pumped the pump one time, and so I got one pump's worth of blue molecules. To contrast that over here in the second image, with that second image, I changed to the red gas molecules and I pumped it one time. And in response to pumping it that one time, the container got bigger because I didn't tell it to hold the volume constant. So as I put more gas into the container expanded to accommodate that gas. The equation that goes with Avogadro's law says that V1 over N1 is equal to V2 over N2. The volume and the amount of gas are directly proportional, so that means as one of these goes up, the other one also goes up. You add more gas to a balloon, its volume is going to increase. Some textbooks include Avogadro's law in their version of the combined gas law, and so their combined gas law looks something like this. P1V1 over N1T1 is equal to P2V2 over N2T2. One of Tyler DeWitt's YouTube videos also takes this approach on the combined gas law. So you can use either form that you want if the number of moles is changing. So you have some sort of a situation where you're adding or removing gas, you do need to take the number of moles of gas into account. So our objective for this video was to look at the relationship between the number of moles of a gas and its volume.